Okay, so we'll do a little more work on homework, and let's start with the number 13. So for 13, you are looking for this, the log of 1 over, and that's 10,000, I believe. 4 zeros, good. Notice there's nothing here, so we need to assume that that's 10. So basically the question is, what power do you raise 10 to get this thing? Well, let's just assume we don't know what it is. So for the moment, I'm going to call it x so that I can rewrite this as 10 to the x equals 1 over 10,000. And this, in fact, again, that trick with tens is that you can count the number of zeros. 1, 2, 3, 4 zeros. So on the bottom we have 10 to the 4th, and I'm just going to write that right-hand side as 10 to the negative 4th. So 10 to the x is 10 to the negative 4th, so x must be negative 4. Let's do another one. Let's do number 14. And this is a little bit interesting. So here we have log in base 5 of 5 to the 9th. So in other words, what power are you going to raise 5 to get this thing? Well, if it doesn't seem obvious, again, let's call that x for the moment. Rewrite this. So 5 to the x equals 5 to the 9th. So x then must be equal to 9. Okay, so this thing is 9. For number 15, we have kind of a similar situation. For 15, we're looking for log. Nothing's written down here, so we know that it's 10. That's the common log of 10 to the p. So in other words, 10 raised to what power is going to give us this thing? Well, again, if you don't know what it is, for the moment, let's call this x and rewrite this. So we have 10 to the x is 10 to the p. So x must be p. So in other words, this thing is p. Well, I'm beginning to think that this might be a property of logarithms. And I'm going to say it like this. If you have log in base a of, notice we have the very same thing, a raised to, let's call it the x power, that's always going to be equal to x. So a little shortcut, like if I asked you for log in base 7 of 7 to the 5th, well, I know that's going to be 5. If I asked you for log in base q of q to the 9th, that has to be 9. Okay, let's keep going. 16 and 17 and 18 are also sort of similar. So for 16, we have log in base 10 of 10. So 10 raised to what power is 10? Well, again, you could call it x for the moment, and say 10 to the x is 10, so x must be equal to 1. But this thing is going to end up being 1. 17, log in base 8 of 8. So 8 raised to what power? 8 raised to what power is going to give us 8? Well, that's obviously a 1. And 18 also, log in base pi of pi. So in other words, pi raised to what power is pi? Well, that's going to give us 1 as well. So I'm beginning to think of another property of logarithms, we might say. Log in base a of a is going to give us 1. A to the first is itself. And 19 through 21, same situation. We have to look for a property here. So here we have log, nothing's written, so I'm going to assume it's base 10 of 1 equals blah. 10 raised to what power is 1? Well, in fact, we know this has got to be 0, right? 0 would make that true. 10 to the 0 power is 1. For number 20, we have log in base pi of 1, right? We need to know what that is. Well, in other words, pi raised to what power is 1? Well, again, that has to be 0. And for 21, log in base 1.2345 of 1 equals, well, this number to what power is going to give us 1? That's got to be 0. So logarithm in any base of 1 is going to give us 0.